In this video, we are going to find positive integers x and y such that x to the power x equals y to the power of y. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. We first establish a lemma before solving this equation. For positive integers a, b, m, and n, with d being the greatest common divisor of m and n, if at the same time we have a to the power m equals b to the power n, then we can find another positive integer c such that a equals c to the power n over d and b equals c to the power m over d. To prove this, we define the p-adic valuation of the symbol nu subscript p of a by some non-negative integer t such that p to the power of t divides a, but multiplying by another t, by another p, which means p to the power t plus 1, will not divide a. And we need to use this for the proof. So since we know that these two perfect powers are equal, then for each prime, the p-adic valuation of a multiplied by m, because it's brought to the m power, will be equal to n times the p-adic valuation of b, because b is brought to the nth power. And since we know that we have the greatest common divisor d, then we can divide both sides by d, and the quotient m over d and n over d are still positive integers. And then we keep the p-adic valuations. Now for these two terms, n over d and m over d, they are coprime. So that means we have n over d divides m over d times the p-adic valuation of a, which tells us that this n over d will only divide the p-adic valuation because it's coprime with the other fraction. So-called fraction, but it's actually also a positive integer. Similarly, we know that m over d will also divide the p-adic valuation of b. Now, since such prime is arbitrary, that means for any prime that divides a, any prime factor, that prime to the power n over d will still be a factor of a. And so that means we can write a equals some number to the power n over d, some integer c that is positive. Then we can go back to our original equation. It's equivalent to c to the power n over d all to the power m equals b to the power n. And then we can rearrange the left side and we have c to the power m over d all to the power n equals b to the power n. And we know c to the power of m over d will be equal to b, which is the other part of the statement that we have to prove. And so we are done. So we're going to focus on this lemma for the rest of the solution. Going back to the main problem, with a tower of powers on the left side, and then y to the y on the right side, and it's close to the condition of the lemma because we can just take the so-called a to be x, and then m to be x to the power of x over here, and then the other exponent will be just y. So using the lemma, we can consider the greatest common divisor of x to the power of x and y. I'm going to let d to be that greatest common divisor. Then we can write x to the power of x to be, say, d times big X, and then y equals d times big Y, so that integers big X and big Y are coprime. From the lemma, we can say that there exists positive integer c such that x equals that positive integer c that we have picked just now, just like the lemma. Now to the power so-called n over d over here. But for our main problem, then it will be small y over d, and that's big Y. While for the other part, which is y, from the lemma, it's also a power of c, but this time it should be using this relation, x to the power of x over d, and that will be big X. And so we can put this back into the equations of the greatest common divisors. So then c to the power y, big Y, all to the power c to the power big Y equals d times big X. And this implies c to the power big Y times c to the power big Y equals d times big X. And at the same time, we have c to the power big X equals d times big Y. Then we have two equations over here. This is the first equation, second equation. To use them together, I'm going to multiply both sides of the first by big Y and multiply both sides of the second by big X. So then both expressions equal to d times big X times big Y. And at this point, I'm going to divide this equation into two cases. The first case would be big Y times c to the power big Y is greater than or equal to x. The reason that I consider this is that both of these expressions are the exponents of powers of c at each side of the equation, and that's over here. So by comparing them, I can kind of simplify the equation. Now for this case, I can say that big Y times c to the power big Y times c to the power big Y minus big X is equal to big X. So now we have Y times the power of c equals to X. But at the same time, the X and the Y are coprime. So the fact that X divides Y times that power of c will tell us that X has to divide the power of c, because X and Y do not share any common prime factors, so all the prime factors at X should appear at the power of c. But we know that Y is another integer, so but on the other hand, this power of c must be, I should say, must not be larger than X, which means these two terms must be equal. And that means Y equals 1. So it's not just X equals to the power of c, we can even simplify that power, and we have c to the power just c minus X. We now have a much simpler equation. But our condition actually tells us over here that Y times the power of c is greater than or equal to X, and that Y is equal to 1. So this means c is greater than or equal to X. So again, I'm going to separate this into two. The first is that c is strictly larger than X, and the second case will be c is equal to X as well. If c is strictly larger than X, then c to the power c minus X will be at least c to the power 1, because the difference of c and X cannot be 0, it's at least 1. And this c is larger than X, but that's not possible. So that means c is equal to X, and so X equals c to the power 0, and that's 1. So c equals 1 as well. But what does this tell about our original equation? Going above, this number is 1, this number is 1, and this number is 1 as well. All the numbers circled are 1. And that means X and Y, small x and small y, has to equal to 1. And that's clearly a valid solution, because then both sides of the original equation will just be 1. Yes, it's a valid solution, and now we can move on to the second case. Given that our first case is set in this way, is that X is the smaller number, so the second case would be Y times c to the power of big Y is less than X. Then I can say that Y equals X times c to the power X minus Y times c to the power Y. And actually, using a similar argument, I can say that big X equals 1. This number has to be 1 because of those coprime things. But then that means this one is even larger than big Y times c to the power big Y, but that's not possible. So we can quickly deduce that there is no solution for this case. And so we can just go back to this and claim that this is the final answer to this problem. Please feel free to share your ideas in the comments. Thank you for watching. See you next time.